Yeah. Good evening, my viewers, and particularly the student friends who are watching or will be watching these videos. Today is June 4, as I have given, and good evening to all of you, and welcome to this session 5 of this particular YouTube, this online tutorial of Environmental Engineering 1 as per AICTE curriculum, as already stated. Okay. Now, see that last time what we discussed, that is that the water treatment plant and how the water supply scheme basically works or so, right from collection from a perennial the surface water source like river or stream or so. That part already discussed, so I'm not wasting time. So now as we went up to the distribution sort of system at the consumer's end also, so from there we will start now, right? So that will be the collection point for the sewage or the domestic wastewater also. So I am erasing this one, right? Quickly erasing this one. Now the hydraulic formula also we have discussed. So for further details you can keep watching this video later. Subsequent videos will will allow you to understand this the hydraulic formula also, right? So I am erasing this also. Now, as I have told earlier in session 4 and also 3, I think I remember that 3 also, if I am correct, right? So that is for water supply or pressure this flow system, that is the water supply pipe this flow so that actually follows the normally we use the formula like Darcy-Weisbach, right, for pressure system, and for also for that the Hazen-Williams, both have been discussed using the formulae for both the cases. And for that for sewage flow, in fact, that is the flow through sewer also, that actually normally follows the Manning's equation also. So we normally use the Manning's equation, and which have already given, but still I am writing here so that it may be referred time to time. This. Now I am just going from this end, that is from the consumer's end, that is the distribution system, where we ended up, that for water supply scheme. From there we are starting for collection of wastewater or from the domestic as well as that commercial as well as institutional establishments also. So suppose these water supply, this network, parallelly the sewage or the sewerage system also will be there, will be laid. So this will be, so I am just giving this way. Suppose this was the for water distribution, the total area also. Now what we are doing actually, that is from building also, that different this systems are there. So we are going like that. Suppose here this is the right. So this is I am showing a very simple kind of network also, and that will be similar to say other areas, community, or for the other parts of the particular this area also, right? So this is a this one. These are all, laterals also. So these are laterals. Now these laterals are maybe here also say. So laterals. So from this laterals actually, from different buildings are there, maybe institutional buildings or residential building also. So these are the sewage is collected from the, through the laterals also, from these establishments also, and then it is emptying into, discharging this into the, sub-mains. Sub-mains. So this is a sub-main, another sub-main also. Ultimately, suppose this will be the main line, suppose for this particular block or cluster. Similarly, for other, this one, the sub-main is coming and joining this main line. Mains also. That means so many mains are there. And ultimately, suppose this is connected to the intercepting sewer also, and this, if I'm just sort of correcting my, because this is hand drawn, so you know that this may not have been drawn with the right alignment also. So this is the intercepting sewer also. From other areas, similarly, the mains are discharging this sewage also, wastewater, from the other areas also to the intercepting sewer, and the intercepting sewer is going to through pumping station also. Let me draw here, this is pumping station. So this is, if we say that this is the main pumping station, MPS. Similarly, suppose there may be one pumping station here because of the area is low, right? So from a lower area, if you want to sort of send your wastewater or so sewage to a higher elevation, then you may require in a particular community or somewhere else also that may have a sort of intermediate pumping station, right? IPS. And so many intermediate pumping stations may be there at different places depending on the requirements. If the land, low-lying land also, for low-lying lands where the gravity flow, because as I have told earlier, you will remember that sewage flow is gravity flow. It is not a pressure flow, normally, unless required. But for when it is pumped also, after pumping, subsequent to pumping, it becomes pressure flow, right? But this then thereafter actually this will be again this gravity flow also, unlike water supply system where normally usually it is always under pressure, and this is pressure flow also. So here actually their intermediate pumping also it is not required. Maybe if it is for boosting also the head, so there the booster pumping stations may be there, but that the purpose is different. Here it is for collection purpose, as I have told. So this actually the main pumping station, or sometimes we also call that terminal pumping station, TPS. Okay, so from where this goes to the treatment plant. It may be kilometers long or so. So length of that actually is decided by the particular areas, this profile or topography also. So this is the sewage treatment plant that we will discuss later, right? How the treatment is done, conventional sewage treatment also, so that is done. So that is the sewage treatment plant, STP. I am not expanding this form because already discussed this. STP is already expanded, this expanded form I have discussed. So ultimately for the disposal also, so somewhere in the downstream with respect to the withdrawal point or so. So that actually is discharge from the sewage treatment plant to the ultimately to the river, right? With proper treatment, depending on the river capability also, and following the standards, permissible standards also, discharge standards. So that is this. So this is the total system. The sewage is collected from the buildings of different types, like domestic establishments. It may be institutional, it may be commercial, it may be minor industries also. But many a time the industries here, you may note that many industries actually, they do not bank or they do not take the water from the municipal pipe network system. They may have their own. So in that case actually, this effluent or discharge also, this may be treated also, right? May be allowed to directly to the municipal sewer line also, depending on the understanding and consultation with the concerned municipality also, whether it would be allowed or not. So that is the case. I am not detailing of this. Now, as you see here, this is the laterals, then via submain, it is going to the mains. So many mains are there. So ultimately these mains are discharging into the intercepting sewer. From intercepting sewer through terminal or main pumping stations also, it is going to the treatment plant, and after treatment also it is going to the ultimate disposal of treated sewage. So this is the disposal line also for ultimate discharge also. So this is it. Okay. Now you see that when we will, one more point, let me tell you that this actually sewage, this you can say the collection, that maybe two types of this. One is this is the sanitary sewerage system, when only the wastewater coming from different these buildings as discussed. So these are collected and then treated also. So this is the sanitary sewerage system. And second is the that storm drainage system. Okay. And third one, although in our country it is not that common also, this is the combined sewerage system. That means when both are combined, right? That means the same sewer line in the sewerage system, same sewer line is carrying the sewage coming from different establishments as just discussed, and also the storm, this part, that means the rainwater, right? So rainwater is collected. You might have seen that by the side of the road, the rain actually collecting system that is there, right? Maybe you might have seen that on the edge of the road, also curved side. So that actually there is a screen like this one, right? So from there actually this may be ultimately collected through that and then connected to the sewer line. Then when this is the case, then this is called the combined sewerage system. But in that case actually what happens during monsoon period, this actually the storm, this quantity of rainwater obviously will be very high, right? So if that is also to be carried as in this combined sewerage system also, then the design of pipe also, the size of the pipe, that will be much more larger, because it has to carry the sewage flow as well as the storm, this drainage or the rainfall or rains occurred. So that rain or the surface flow also from the rain, so that also will join. So that is why this is difficult, because it will be unnecessarily larger during monsoon period, it will be there, but during other period, if that bigger pipeline that is there, then it will be carrying very low flow. That means suppose this is a combined one. Let me draw here. See that this is suppose combined. So in that case, during monsoon period, it may flow almost, running full or so, it may flow that way, full. But when non-monsoon period, that may be this, because only sewage will be collected. There is no rain during non-monsoon, dry period, right? So in that case, actually, there is, that would be underutilized, this pipe. And also because of the very low flow also, the deposition of solids will take place in the pipe itself, which is not desirable. So that is why we normally avoid combined sewerage system. In case of this, that separate sewerage system also, so this will be separately, collected. That means in case of separate system, this is combined. This is, that this is the, let me use the separate system, that one is for the sewage, that's the sewer line, that is for the sewage, carrying sewage, and another they run parallelly also, that is for the storm or rain water transmission also, storm water, right? So that is the separate system. This is the combined system, right? So I think it is clear. If you want to sort of, get it further clear also, then in that case we can, either meet through this Google for the registered participants also, and if someone wants to ask something on the free demo video also, they can do through mail also, that they can also, I can address that one, but not in details, because that scope is not there, right? For unregistered students also, or free demo. So this is free demo session 5. Okay. Now, how would you find out, that next thing is that, how would you find out, let me erase this one, right? So how would you find out, I'm erasing all this because which have already have been discussed, right? Just to create space for this discussion and drawings also. So now you see that we have to, in case of the sanitary sewerage system, we have to estimation of sanitary sewage, right? Now in this case actually sanitary sewage, regarding estimation of that actually, so what you have to do this, just one more. Okay. Now for the sanitary sewage, what we do actually, the water supply which has been the water which has been supplied, the quantity of water also, for actually sanitary sewage which is coming from the different units also, that is institutional, commercial, mainly the domestic also. So part of that will come or will be collected as sanitary sewage. Okay, not full. So normally actually what is there, depending on different factors also. So the and extent of the sewerage system, collection network also. So depending on that, 40% to say 90% of the water supplied also from to each and building. From those buildings actually 40 to 90% depending on the extent of the coverage, then workmanship of the sewerage system also, depending on several other factors also. That the area, whether it is very dry, then evaporation will be more, infiltration will be there. So that is why actually this varies so widely, that is 40 to 90%. If the sewerage system is very strong in the sense that it is almost entire area is laid with the sewer or so, then in that case it may go as high as 90%. But if it is suppose not, sewerage system is not that wide or so, laid widely, then in that case it may come down as 40% or so. Normally it is taken as 80% of water supply, normal design. Okay, but remember that minimum should be 100 liters per capita per day. Clear? Minimum 100 liter per capita per day, that will be the minimum. Now, to that actually, this is the case, and if industries separately discharge also, that is to be calculated separately also. May be that different industries are discharging with that with consent of the concerned municipalities or corporation also, then in that case separately this has to be estimated also, flow. Otherwise that 80% normally, unless otherwise mentioned also, of water supply will be coming as sewage also, or minimum this, right? So this is this, and then you see that because the space is small, relatively, so that I have to create space, so that is why I am erasing this one, and it is recorded so you can get it always back. Now this actually, you see that we have to add to that. So this is the sewage which is coming from that, that is to be calculated, plus is that add the groundwater infiltration.